Sean Thompson is a PhD student in the Department of Soil and Crop Sciences. He works with Dirk Hayes, Robert Washington Allen, Jackie Rudd, and myself. And he's looking at below and above ground traits using high throughput phenotyping technologies. For that, he's using the ground penetrating radar and the terrestrial laser scanning tools to look at traits that we have not been able to look at in the past.
The real use of the terrestrial laser scanner in a plant breeding population is it allows us to access or to see phenotypes that we haven't been able to see in the past. So as a plant breeder, when we walk out into our nurseries, we walk through our nurseries and we look for characteristics or physiological traits in plants and in lines that give it an advantage over another plant. And so in this case, just as this nursery behind me here, we would go into this nursery and we take plant height measurements, and some of those measurements can be correlated to yield, or some of those measurements can be correlated to the performance of that plant, or we'll take an agronomic score. But as you can see, this is one of many of the nurseries that we use here in Texas to evaluate our lines. And the problem is that over time, or even as the course of the day progresses, we become biased to different things that we're scoring these lines for, or we become tired, or we become hungry, or the bottom line is you just can't see enough of the diversity in the plants or see the differences because they're so minute between two lines. And so it opens the door for a need for this technology that allows us to take data rapidly but very accurately, and that's where these tools come into play. For the ground penetrating radar, the idea behind it was originally designed to look into like concrete, to be able to find rebar, to find underground pipes or find underground water. And it's been utilized by other scientists for work such as in forestry, where they're looking at below ground canopy of a tree, being able to image the roots that are below ground, or being able to look and see into the structure that the plant itself is actually putting down. So it's a very simple idea. Like I said, the radar it sends a signal down into the ground, and what the idea, or what the concept is that as the signal passes through the soil, when it encounters a root or when it encounters anything else that is in the soil, it's going to send back a return that's different, showing a different density or surrounding. One of the ideas or the hypotheses that we have is that plants that have deeper roots can tap into water, or plants that have larger below ground biomass or larger root systems are able to withstand drought better. And with changing environmental pressures and with stresses that are being put on these lines and on our wheat lines in our populations, we feel that being able to evaluate these would be our next big move for us as far as developing lines that are able to handle drought stress or able to handle heat stress.